I've built a floating point binary to decimal converter in Excel VBA, and this is the interface here. So we're going to have the floating point binary numbers here. We've got the sine, the exponent and the mantissa. We're going to have the decimal number here, and we can clear and we can close the form. So whenever we run through it, we just toggle these buttons, and you can see this has been toggled to a 1 and that's been toggled to a 1, and these have been toggled to 1s, and you can see the output here is tending towards 5.2. so this is a repeated conversion, so it's an approximation. So let's go ahead and we'll see how we're going to build this in Excel VBA. If you head into the resources section, you'll see there's an Excel file there called float to decimal. So if you open that up, you'll see there's just one page. It's called FTD. Now we don't need to bother about what's on the page here for the moment. All we're interested in is this button in the corner. So the button in the left hand corner, it says FTD. It just stands for float to decimal. So if you click on that, you'll see the interface coming up, and it's a simple interface. It tells you it's a floating point binary decimal converter, and we have the little buttons here that we can press. So at the moment it's all sitting at zeros, so the decimal should give you a value of 0, which is correct. So what we can do is we can change this. So we'll put the value 5.2. So the value 5.2, you'll see it building up gradually as we put these in. So there's this one and this one and this here, and you see as we add these here, we're starting to get closer and closer to this one, 5.2. So this here is the approximation to the number, decimal number 5.2. So it means that you can use the tool in order to see every floating point number being converted into the decimal equivalent, and then you can just clear it and you can start again. So you can just mess about with this. And I've also added in the other values here, which for example are going to be the plus infinity, the minus infinity, and there's also going to be the not a number, and there's also going to be the signalling not a number. So you can open that up and have a mess about with it. It's quite useful to get an understanding of the floating point numbers and get used to looking at them. So let's have a wee look and see how this actually operates in the code for it. So you can just press the close button, and then we can come up to the developer tab and click on Visual Basic. That's the top left hand corner, and then you can come down to the forms. So you'll see the form called f_d. Let's see, you can see it actually, there we go. So that's the form here, maybe a little bit smaller there, but you can just about see it. It's forms and it's called f_d. So double click on that and you'll see it's going to open up the form for us. So what we can do is we can head into the actual code. So you can just click any of the buttons here. So we'll just click the first button up here and it'll take you into the code. So run up to the very top, and this is this top of our code. So let's talk our way through this now. So I'm not saying that this is necessarily the best way of writing this code, and I'm no Excel VBA guru, but it gives you an indication of how to write it if you decide to write something like this yourself. And of course you can always make it a bit better and a bit swisher than this if you like. So I've started off, all of the variables have just been defined globally because it's just a small bit of code, so we're not really going to get mixed up with it. So I've defined the sine, and also the exponent here is the sine in exp 1, 2, 3 all the way to 8, and I've defined the mantissa from 1 to 23. Now probably after I've worked through this code, I thought it'd probably been better to put them all into an array and then read them out of an array. It's probably a bit smarter, and I may well do that later on, but this works for now. So first thing to look at is if you come up to the top here and head down to the user form, and there's another pull down there which is, and you could head into initialize. So it just shows you how whenever the user form opens up, how it's initialized. So it's going to be initialized by calling this clear function. So where's the clear function? The clear function is here, and all it does is it untoggles all of the buttons. So if any of the buttons have been pressed, this toggle button dot one value equals false will just unpress them, and it will set all of the values of the toggle buttons to 0. Okay, so all of the variables will all be set to a value of 0. So it's just initializing all your variables, and this here will run through and it will set all of the values that are actually on the spreadsheet to a value 0 as well, because I made a copy of them onto the spreadsheet. So at this point the user form will have ran up and you'll be able to press all of the toggle buttons. So here are all the toggle buttons up here, and there's not much to it really. So there's going to be 32 of these toggle buttons. So the first one is going to be used for the sign, and then the next one is used for the next 8 are going to be used for the exponent, and then the 23 will be used for the mantissa. So if you look in each of these, all it does is it checks to see whether the value is 1. If it's already 1, it sets it to 0. If it's not, it leaves it at 1. So this is just a toggle operation. So it's just a little toggle operation, and this is the same in every single one. And then we set the value of the variable here, sign, or exp1, exp2, and so on and so forth. We set these to the value of the caption which is in the toggle button, which is going to be either a 1 or a 0, and also copy it through to the actual spreadsheet page here as well. And every single one of these 32 boxes are exactly the same, they just do the same thing. And finally, what we want to do is, once we've set the toggle correctly and we've read the value into the variable, we're going to call the actual function. So we'll call the conversion function. So we do that in each of them, we'll call that conversion function. So let's have a look and see. Now the conversion functions is the actual the interesting part, and this is everything we had to do in order to convert from our binary to our decimal. So this is the conversion here. So let's have a little talk through this now. So this is the conversion section here. We've got just some local variables that are used within this sub in the conversion section, and the exponent and the mantissa, I create these just by joining together these values here. Okay, so this is the individual 1s and 0s that you get whenever you press the toggle buttons. So this might be 0, 1, 0, 1, 0, 1. So the exponent comes out here and it just joins them all together, so they're ANDed together. And they do the same with the mantissa, so it will create a 23-bit value for the mantissa. So what we want to do now is talk through all of the cases that we have, but to do that we'll have a little look and as a reminder of what the cases are and what we have to do to get them. So we've seen this from a previous video. We're interested in the 8 cases that we have here. So we have the special case whenever the exponent is all 1s, and a special case when the exponent is all 0s. So whenever it's all 1s, if the sign is 0 and the mantissa is all 0s, it's plus infinity, and if the sign is 1 and the mantissa is 0, then it's minus infinity. And then for the other 2 cases we don't care about the sign, but for the not a number, if the first bit of the mantissa is a 1 and we don't care about the rest of these, then we get a quiet not a number. And if the first number is a 0 and we'll have at least one of these other 23 bits will be a 1, then we're going to have a signalling not a number. And we've seen previously that if the exponent is actually 0, then we're going and the sign is 0 and mantissa is 0, we'll have a 0 plus, and if it was a 1, we'll have a 0 minus, although we just made this a single 0, okay, I didn't bother with a 0 plus and a 0 minus. And of course we got the denormal numbers will occur whenever the exponent is a 0 and we don't have a 0 for the mantissa. So we have to code these in, and also we'll have to code in and make sure it actually does the normal numbers and the denormal. So let's go ahead and we'll see how we've coded these in. So at the moment these numbers, the exponent and the mantissa, are actually still defined as integers, they're actual doubles, but they only contain ones or zeros at the moment. So we can treat them as, if you like, binary numbers. So we can do a test. We just simply look and say, well, if the exponent is all ones, okay, so this is going to be 4 different cases. So the exponent is all ones and the sign is 0 and the mantissa has got 23 zeros, then the output, which is a text box, is plus infinity, and we just finish up. And again, if the sign is 1 and the mantissa is all zeros, then it's minus infinity. Now we can also test here for the not a number, the quiet and the signalling, because we can also treat this number here, as opposed to treating it as a binary number, we can actually treat it as if it was actually just a decimal number. So it means that any number that is greater than or equal to 1e to the power of 22, so that's 1 with 22 nothings, then it's going to be a quiet nan. And then any number that is greater than 0 and less than 1e to the 22, we can treat this as a signalling nan. So in this instance here, we're kind of cheating a little bit. We're taking the exponent and we're treating it both as a binary and also as a decimal, but it works okay and we get the right values. So if we have the other option here, whenever the exponent is all zeros, then we can set the value for the 0. So if the sign is 0 and mantissa is all zeros, we can set the output to a value of 0. And also if the sign is 1 and mantissa all zeros, we can set the output to 0. So by rights we should set these to plus and minus 0, but we're not going to bother with that detail, we'll just leave it as a value of 0. So let's head back down and we'll continue and we'll look at how we're going to generate the normalized and the denormalized or subnormal numbers. So almost finished, just this little section here. Now we set the mantissa to 0, and then in order to get the value for the mantissa, so remember the mantissa is going to be a value of, say, 1 upon 2 plus 1 upon 4, 1 upon 8, 1 upon 16, 1 upon 32, so on and so forth. So we actually read off from the spreadsheet the values, whether the output is actually a 1 or a 0, because we've got a copy of it on the spreadsheet. And then all we need to do is generate the new value for the mantissa, which will be the old value of the mantissa times 2 to the power of the value of this count, and it's a negative value because it's going to be 2 to the minus 1, 2 to the minus 2, 2 to the minus 3, 4, all the way up to possibly 23. So every time it sees a 1, it's going to add that value on. So that's how it generates the little mantissa. Now we're interested in the exponent, but we're interested in whether the exponent is actually equal all zeros. Now if it's all zeros, then we know it's going to be a denormalized number. So if it's denormalized, then we know that the actual function that we use is this minus 1 to the power of the sign times the 0 plus mantissa times 2 to the power of minus 126. But of course, in order to get this, we have to get the actual value for the sign. So we've got to change the sign from a binary number into the decimal number. So we change that here with a worksheet function, and it's going to be binary to decimal. So that changes it to the decimal number which we require in order to work this out. And now once we've worked that out, again we just output the result to the text box. And then we have one other option, which is if they aren't all zeros in the exponent, then we'd use the normalized form, and again we change the exponent to a decimal value using the worksheet function, but now we use the normalized form, which is -1 to the power of sine times 1 plus mantissa times 2 to the power of exponent -127, and we output the result in the text box again. So that's the end of the program. The only bit of real coding in it is just this little section here. Really the rest of it is just to make a nice user interface. So I hope that was of use to you, and it shows you that in order to create these conversions, they're relatively simple and they can be quite compact. So thank you for listening. I'll get you on the next video. Goodbye.